Hi everyone. Today we're going to study integration of power series. Let the function f of x equals the summation from n equals 0 up to infinity of a sub n times x raised to n. We can expand this into a sub 0 plus a sub 1 times x plus a sub 2 times x squared plus a sub 3 times x cubed plus and so on. Now we will integrate the f of x term by term. We can show that this is the integral of f of x dx. Integrating term by term, this a sub 0 now becomes the integral of a sub 0 dx plus the next term, the integral of a sub 1 times x dx plus the integral of a sub 2 times x squared dx plus the integral of a sub 3 times x cubed dx plus and so on. Simplifying this, we will have a sub 0 x plus a sub 1 times the fraction x squared over 2 plus a sub 2 times x cubed over 3 plus a sub 3 times x raised to 4 over 4 plus and so on. With this new series, we can write this into sigma notation like summation from n equals 0 up to infinity of a sub n times the fraction with numerator x that is raised to n plus 1 all over n plus 1 and then the plus c. Let us see example 1. Integrate the power series summation from n equals 0 up to infinity of the quantity x plus 5 is raised to n, term by term. Let us expand the series into the quantity x plus 5 is raised to 0 plus the quantity x plus 5 raised to 1 plus x plus 5 then raised to 2 plus and so on. Now let us integrate the series one by one or term by term. So the integral of this quantity x plus 5 raised to 0 dx plus the integral of the quantity x plus 5 dx plus the integral of the square of the quantity x plus 5 dx plus and so on. When we simplify each of the terms, the first term becomes x plus 5 plus the integral of this becomes the square of the quantity x plus 5 all over 2 plus the integral of this expression here now becomes the cube of x plus 5 all over 3 plus and so on. We can write this now into sigma notation like this. Summation from n equals 0 up to infinity of this x plus 5 that is raised to n plus 1 all over n plus 1. This is our answer. Example 2. Integrate the power series 1 over 1 minus t equals 1 plus t plus t squared plus t cubed plus and so on, such that the absolute value of t is less than 1. Remember, this is also a geometric series, and hence obtain a logarithmic series, that is series for the natural log of the absolute value 1 plus t. First, let us integrate term by term. Let us show that we want the integral of 1 over the quantity 1 minus t, then dt. So we have here now the integral of 1 dt plus the integral of t dt plus the integral of t square dt plus the integral of t cube dt plus and so on. Simplifying each of the terms, we have now t plus t square over 2 plus t cube over 3 plus t power 4 over 4 plus and so on. This new series here is actually equal to the negative of the natural log of the absolute value of the quantity 1 minus t. After taking the integral of each of the terms, we're going to find a logarithmic series for this ln of the absolute value 1 plus t. Using this expression here, first we're going to multiply this equation by negative 1 so that the left side becomes positive. So it will be like this. The left side now becomes positive natural log of the absolute value 1 minus t equals the right side members is now multiplied by negative 1. The next objective now is to make this negative t to be positive so that it will be equal to our expression in here. What we're going to do, we're going to change t by negative t. So this negative t here becomes positive t. So the left side becomes ln of the absolute value 1 plus t equals, for the right side, all t will now be changed into negative t. And then, let us simplify each of the terms. So the first term here, the negative t, becomes positive t. When we simplify the second term, it becomes the negative of t squared over 2 plus, simplifying the third term with respect to the negative sign outside, it becomes positive t cubed over 3. Simplifying the fourth term, this negative t that is raised to 4 all over 4, and there is negative sign outside here, we have the negative t raised to 4 over 4 plus and so on. We can see here that we have alternating signs for the terms. So this is the series for the natural log of the absolute value 1 plus t. This is now the final answer. I hope you learned something from this video. See you again next time.